Alright folks, today I'm going to discuss question 38 from HSC 2024 chemistry paper. Question 38. Compounds A and B are isomers with formula C3H7X, where X is a halogen. The mass spectrum for compound A is shown. This is where I'm going to focus my attention. If we look at the relative intensities of these two, we can say that is as a 1-to-1 ratio of relative intensity. That's 1, that's 1, 2, so that one's 122, and this one is 2, 3, 4, 124. This is bromine. The reason this is bromine and not chlorine, if you have that's 1, that's 3, then it's chlorine. So then our molecular formula would then be C3H7 bromine. In terms of a linear chain configuration, there's only 2. In this version, we're going to put the Br at the terminal. We can draw in our hydrogens. And then this one, we're going to put it in the middle. And we're going to draw in the hydrogens. And as you can see, why they are isomers. Compounds A and B undergo substitution reaction in the presence of hydroxide ions. This part is a substitution reaction. Br is going to be switched to hydroxide, producing alcohols C and D. Compound D can be oxidized to a ketone. Compound C can also be oxidized, but not to produce a ketone. Compound A is this one, and compound B is this one. So here's our compound A. It's going to undergo substitution. We're going to be switching places between these two. And so what I end up is propanol. B also undergoes substitution reaction. B goes to D, and then it was further oxidized to ketone. So then we're going to get structure D. So in this part, we're going to figure out what compound E is. So compound C is 1-propanol. Compound D. Let's draw 3-methyl-butanoic acid. So we have 4 carbons. It's a butanoic acid, so I know that one end of the structure will need a carboxylic acid. This becomes the priority carbon. So let's do our nomenclature. This becomes 1, 2, 3, 4. The question says the methyl group is on the 3rd position. So that's 3-methyl-butanoic acid. Compound E can be produced by refluxing 3-methyl-butanoic acid with one of the alcohols C and D in the presence of the catalyst. So what we have here is an esterification reaction. In the presence of the catalyst would be catalytic amount of H2SO4. So basically we're going to replace this hydrogen with this part or this part. We are now going to use proton NMR to figure out which combination is correct. Okay, so in this part we are going to go through E1, predict what we should expect to see for the proton NMR profiles, and then compare that with the data given in the question and see how well we match up to the expected and the actual data. Alright, let's get going. So the first thing is we need to map out how many sorts of hydrogens we have across the carbon backbone. So we have 1 here, so that's A, B, C, D, E, F, G. I'm currently keeping F and G as separate, but essentially they're the same thing because there is symmetry there. So if I was to draw the condensed version of this structure, you'll know what I mean. So this is how we draw the condensed version. Okay, so if we draw the condensed version, you can see that if I put a series of dashed line over it, CH3F and CH33G is the same. Okay, so essentially they are the same thing, but for starters now, I'm just keeping it separate. So why don't I just make a note that F equals G for clarity. Okay, so now we're just going to go through each of the parts and assign what we think the answer should be multiplicity wise. Right, so let's go A. A is CH3, has 3 hydrogens. Now CH3, this A, is only going to see B. So that's 2 plus 1, so that's a triplet. B is going to be B is going to see A and is going to see C. So let's do that first. CH2, 2H. So when B sees A, it sees a quartet, and when B sees C, is going to see a triplet. We can combine those two to say that it's a multiplet. At the high school level, you are not equipped to figure out the combination of Q and T. There's something called J coupling, but we're not going to go there. So we can just very easily and in a very relaxed manner say that's M for short for multiplicity, multiplet. Right, so then C is, let's get rid of all that. C is CH2 and 2H. C is going to see B, so it's a triplet. Right. Now we're going to the left-hand side of the molecule. We're going to go to D. Just move all these closer so we know what's going on. Oops. Put it there. Okay. Right. So D is going to be seeing E. In terms of the structure, D is too far away from F and G, so it's not going to see the hydrogens of F and G. It's only going to see E. So since E is one hydrogen, it's going to be a doublet. Right, so CH2, 2 hydrogens, and a doublet. Okay, so we're going to go to E. E is, the way we're going to draw this is like this. So it's very clear which carbon hydrogen belongs to. Now, as you can see, it's now very evident that F and G are the same thing. Okay, so we're going to put 1 hydrogen. Right. Now, this hydrogen actually sees both G and F and D. Alright? Now, this hydrogen, when it sees F and G, it's going to be 6 plus 1. It's going to be a septet. And the hydrogen that sees D is going to be a triplet. Alright, because it's 2 plus 1. So again, that becomes quite a complex set of data. And we're going to just go, thank you very much. We'll put it as multiplet. Alright, so we're just going to do that instead. So it's multiplet. Alright, so then since F and G are the same thing, alright, that's what we have. And we're going to have 6 hydrogens. And since all the hydrogens are equivalent, we are going to show each of the CH3 as one signal. And so it's next to another one signal. So this becomes a doublet, because then 1 plus 1 equals 2, which is a doublet. Alright, so we're going to now go back and have a look at what we have to see how it matches with the proton NMR that's provided in the question. So in this part, I'm going to compare what I predicted for E1 to the actual data provided by the question. So we're going to go through it. So 0.5, 3, and the triplet. So that is A. 0.966 integration doublet. So that is these two. Alright, so that's F and G. Right, so there's A and then F and G. Right, the next one is multiplet to 1.7, and that is B, because the other multiplet is 1, so it can't be B. 2.1 is 1 is a multiplet. The only multiplet that is 1 is E. So that's E. (2.2) 2 protons doublet is D. And then our final one is C, which is 4.02 triplet. Thank you for watching, and I'll see you next time.